So for number one, looking at this, we have two terms on the bottom, so I know I'm not going to be able to separate this. And so it looks like this might be a good u substitution problem. And so I'm going to let u be x squared plus 1. du dx is going to be 2x. And then when I solve for dx, I have du over 2x equals dx. And now we're going to go back and resub. So I have x over u. And in place of dx, I'm going to have du over 2x. And again, those x's should cancel. And then I'm going to move this 2 out. So I have negative 1/2 times the integral of 1 over u. And so notice here we have everything working out nice and neat. So we need to adjust our endpoints. So I'm going to plug in 3. And 3 plugged in down here is going to give us 9 plus 1. And then 1 plugged in down here is going to give us 2. And so we're going to have here negative 1/2. And then our integral from 10 to 2 of 1 over u, that's going to turn into natural log of u, and then absolute value of u, and it's going to be evaluated from 2 to 10. And so we're going to have negative 1/2 times natural log of 10 minus natural log of 2. And a couple of ways they could rewrite this, especially since we have logarithms that are subtracting. I can rewrite this to be the natural log of 10 over 2, which is going to be natural log of 5. All right, let's look at our next example. And here, instead of going right away to natural logarithm, notice this is just one term, or not natural log, u sub. This is just one term in the bottom. So I'm going to divide this up, and I'm going to look at this as the integral of 4x cubed over x to the 4th minus 2 over x to the 4th dx. And then from here we can simplify those exponents, and so that's going to leave me with 4 over x minus, then I'm just going to move that integral through, 2 over x to the 4th, and then dx. And so here, this first one, we can move this 4 out, and that's 4 times the integral of 1 over x dx minus, and I'm going to move my 2 out, and this x to the 4th, I need to flip that over. That's going to be x to the negative 4 dx. Now from this portion here, if I integrate 1 over x, I get natural log, absolute value of x, and then minus 2 times, and if I integrate x to the 4th, remember you add 1. That tells you what to divide by. So I'm going to have x to the negative 3 over negative 3, and then plus c. And they'll probably change up a little bit how that looks on your multiple choice. All right, so number 3 now, moving on. We're going to, again, we have e with the really terrible looking exponent. So that tells me I probably need to do a u sub, and that u is more than likely going to be that exponent. So then du dx is going to be 4x cubed plus 4x. And right away, if we start trying to compare this to what we have over here, it's pretty close to what we need. It does look like we need to factor out a 4. And then we do need to solve for dx. So dx is going to go over there, and the other is going to move back. So I'm going to have du over, I'm going to go ahead and factor out that 4. That's going to give us x cubed plus x equals dx, and right away we're seeing that this is going to cancel with this, so that's good. That's what I need to happen. We're going to have an extra 4 here, so I am going to move out that 4. That's going to be 1/4 times the integral, and so we've got e to the u du, and we do need to adjust our endpoints. So again, we're going to plug in 1 over here, so that's going to give me 3. And then I'm going to plug in 0, and that's going to give me 0. And now we're ready to integrate this. So I have 1/4 times. If I integrate e to the u, I get e to the u evaluated from 0 to 3. So this is going to be e cubed. It's going to be your top endpoint minus, and then sub in your bottom endpoint, and e to the 0 is 1. All right. And we don't have anything else there. All right, let's move on to number 4. Again, looking at this, we are all over one term, so I'm going to divide this up, and I'm going to have the integral from 1 to e squared of x squared over x plus 1 over x. And then that's going to reduce down, so I have from 1 to e squared of x plus 1 over x. And now this has turned out nice and neat. We can go through and do our integration. So if we integrate x, we're going to have x to the second over 2 plus, and if we integrate 1 over x, we get natural log, absolute value of x. And now we need to evaluate this from 1 to e squared. And so substituting in, we're going to have e squared all squared, so that's e to the 4th over 2 plus natural log of e squared. So there's our first endpoint, and then it's going to be minus, and we plug in our other endpoint. And so if we plug in 1, we have 1/2 plus the natural log of 1. So simplifying here, we have e to the 4th over 2 plus, here natural log of e all squared, it's just going to be 2, minus 1/2, and then the natural log of 1 is 0. And so finally, it looks like we can put these together, and we have e to the 4th over 2 plus 3/2. Okay, our next problem looks like we're going to have another u substitution, and we're going to let u be that exponent of e. du dx is going to be negative 2x. And again, solving for dx, we're going to have du over negative 2x. And so when we come back up here, we do have x, e to the u, and dx is du over negative 2x. Those x's are going to cancel. We're going to move out our negative 2. So we're going to have negative 1/2 times e to the u du. And then again, we need to adjust our endpoints. So we're going to sub in those original endpoints. So that's going to be negative 2. And then for the bottom, it's going to be negative 1. And notice we are not going in order with our endpoints, so we are going to change 1/2 to positive and change our endpoints. So from negative 2 to negative 1 of e to the u. And so that's going to lead to 1/2 times e to the negative 1 minus e to the negative 2. And that's going to give us 1/2 times 1 over e minus 1 over e squared. All right, moving on to number 6. Again, this looks like a u sub. So we're going to let u equal negative 2x. du dx is going to be negative 2. And so du over negative 2 equals dx. So back up here, again, we're going to have e to the u, and then we're going to have du over negative 2. So we're going to move out that negative 2, and we now need to adjust our endpoints. And so when we adjust those endpoints, we are taking natural log of 3 and substituting it in. So we're going to get, so the top endpoint is going to be negative 2 natural log 3. And then the bottom endpoint is going to be 0. So again, we do need to change our endpoints. So we're going to have a positive 1/2 integral. And that's going to be from -2 natural log 3 up to 0 of e to the u du. And again, we need to go through now and do our integration. So we're going to have 1/2 times e to the 0 minus e to the -2 natural log of 3. And it could be left that way. You could also see e to the 0 is 1 minus, and this -2 right here could move up to be an exponent, so that would be e to the natural log of 3 to the -2. And that could even simplify down further. However, I'm not real sure you would need to, but that would turn into 1 minus 3 to the -2, and you can do the math on from there. Right, this next problem, we need to use the fact that e raised to the natural log of x is just going to reduce down to bx. So in our rewriting process, this is going to give us x over x dx. And from here, that means we're integrating from 1 to 10 of 1 dx, or sometimes you could see this integrated from 1 to 10 of dx. Both of which, if we integrate that, that's just going to leave us x, and that's going to be evaluated from 1 to 10. So we're going to have 10 minus 1, which is 9. All right, moving on to number 8. And again, it looks very complicated, but I would do a u substitution here. I would let u be the natural log of x, because again, that's our inside function here. So du dx is going to be 1 over x. And so in our rearranging process, here I would move our dx over. So du is going to be equal to 1 over x dx. And so I'm going to multiply or divide both sides by 1 over x. If you want to do that, you're welcome to. And if I have here, this is really dividing by 1 over x, so this is going to flip over. So I'm going to have x du equals dx. So when we come back over here and substitute in, we're going to have u squared over x, and then dx is x times du. Now, those are going to cancel, so let's go ahead and adjust our endpoints. So I'm going to substitute in e squared, and natural log of e squared is just 2. And if I plug in a 1 over here, natural log of 1 is 0. And so now we're ready to finish our integration. So here we're going to get u to the 3rd over 3, and we are evaluating that from 0 to 2. So that's going to give us 2 cubed over 3, which is going to give us 8/3, and then minus 0, so just 8/3. All right, so again, strange looking problem. I would pick on this portion right here, and I would let u be -1 over x, or x to the -1, same thing. And so du dx is going to be x raised to the -2, which is 1 over x squared. And solving for dx, we can multiply the x squared over. So I have x squared times du over dx equals 1, and then I can multiply both sides by dx. So I have x squared du equals dx. Now we can come back and do our substitution, and we're seeing that this is going to work out. So I'm going to have e to the u, and then over x squared, and then filling in, we're going to have x squared du. And now we're going to go adjust our endpoints. So if I plug in a 2 here, that's going to be a -1/2. And then at the bottom, I'm going to have -1. And so we are going, -1/2 is larger than -1. So we're okay to go ahead and do our integration. So I'm going to have e to the u, and then I'm going to integrate or evaluate that from -1 to -1/2. And so we're going to have e to the -1/2 minus e to the -1. And that's going to translate to be 1 over the square root of e minus 1 over e. And that's probably as far as you'll see that problem worked. Okay, for our next problem, we're going to let u be 2 minus x squared. So du dx, it's going to be -2x. And so solving for dx, we have du over -2x equals dx. And now let's go back up and check. We're going to have an integration. We're going to have x over u, and in place of du, we're going to or dx, we have du over -2x. And again, those x's do cancel. And so we're going to integrate 1 over u du. And here, plug in our endpoints and adjust those. So we're going to have 1. If I plug in 0, I'm going to have 2. So our endpoints are inverted, so we need to flip those back around. And so now we're ready to do our integration process. So we have negative natural log, absolute value of u, and we're evaluating that from 1 to 2. So that's negative natural log. And I'm just going to leave that negative on the outside. And that's going to be the natural log of 2 minus the natural log of 1. And so natural log of 1 is 0. So I have negative natural log of 2. Or they could rewrite this by taking that negative and moving it up to the top. And that would be natural log of 1/2. So either one of those would be the correct answer. All right, moving on to our next problem. And again, this is another example of knowing some of these little tricks with our logarithms. This 3 can be moved up, so we can rewrite this to be e to the natural log of x cubed dx. And e to the natural log, here all of that's going to cancel. And so I'm going to be left with the integral of x cubed dx. And then that simplifies just to be x to the 4th over 4 plus c. All right, our next problem. This one we can pull apart. Notice if we're adding exponents, we were multiplying with like bases to begin with. So I'm going to separate this out and write it like this. And so here again in our process, e squared is just a number, so move that out. And I'm going to integrate e to the natural log of x as just x dx. And so here we're going to have e squared times x squared over 2, and that's a value. Oh, nope, it's not evaluated. Sorry, guys. We need to put our plus c because we don't have endpoints there. Okay, our next problem. I'm going to rewrite this so that we can see kind of what's going on here. That is e to the 1/3 times x. And so we see we can do a u sub with this. And so du dx is going to be 1/3. And again, solving for dx, we can do our cross multiplying if you want to save yourself some steps. So 3 times du equals dx. And so when we come back up here, we do have 1/3. And then that's going to be integrating e to the u, and then dx is going to be 3 du. And so again, that 3 is going to move out, and it will actually cancel with that 1/3. So we are integrating e to the u du, which is going to give me just e to the u. But again, we don't have our endpoint, so let's go back and resub in what we started with, and then plus c. Right, for tangent, we do need to rewrite this because it does change how we're going to look at it. Tangent is going to be your sine x over cosine x. And we're going to do a u sub here. I'm going to let u be cosine x. So du dx is going to be negative sine x. And again, solving, we have du over negative sine x. That's going to be equal to dx. And so we're going to come back up here and resub in. So I have the integral, have sine x over u, and dx is du over negative sine x. We are going to cancel those, and we have a negative. We're going to move out to the front. So I have negative integral of 1 over u du, and I know that's going to be natural log. So negative natural log, absolute value, and 1 over u, here our u value was originally cosine of x. And then we have our plus c. Now that is one way to write it. The other way, or if we wanted to remove that negative, then we can rewrite that to be natural log absolute value of secant x, because that negative could have moved up and become an exponent here, and that's going to make that secant x. And then, of course, plus c. All right, moving on to our next problem. For cotangent, we can do something very similar. We can go ahead and rewrite this. We're going to do the integral, and this is going to be cosine over sine. And again, not du dx. And again, we can do a u sub. I'm going to let u be sine of x. So du dx is going to be cosine x. And so solving for this, we're going to have du over cosine x equals dx. And so when we go back and resub in, we see that those cosine x's, I hope, are going to cancel. We have du over cosine x, and they do cancel. And so I have the integral of 1 over u du again. I know that's going to be natural log absolute value of u, but u was originally sine x. All right, so now let's move on to our next problem. And this looks absolutely horrendous, but again, this is one of those strange little integration problems that we're going to go through. We have a transcendental function here. When you see this, you can think about in terms of e, and I'm going to make our u sub going to be that exponent. We have u is negative sine x, so du dx is going to be negative cosine x. And solving for our dx, we have du over negative cosine x equals dx. And so integrating, we have cosine x times 2 raised to the u power, and dx is du over negative cosine x. So we see that our u sub is going to work, so that's good. And we're going to cancel out those cosines, and I have that negative I'm going to put out front, and then we're going to integrate 2 raised to the u power du. Now we do need to adjust our endpoints, so I'm going to plug in pi over 6. And when I do that, sine of pi over 6 is 1/2, and it's got a negative there, so that's negative 1/2. If I plug in a 0 over there, then that's going to give me 0. Now I need to flip over my endpoint, so that's going to change to be 2 to the u du. And then that's going to flip this over, and so I have 0 and I have negative 1/2. So 2 to the u is going to be, if I integrate that, it's going to be still 2 raised to the u power over the natural log of 2. It's just a formula, and we will be evaluating that from negative 1/2 to 0. And so for that, we're just plugging in our values for u. And so really we can think of this as 2 raised to the 0, which is 1. So that's 1 over natural log of 2. And then we're going to have minus, and then that's 2 to the negative 1/2 over natural log of 2. And you could move that down. I'm out of room here, but move this down to the denominator. So that would have been a square root of 2 down there and a 1 left on top. And again, we have another u sub, and we were going to pick on this little exponent here. So u is going to be negative x squared. Du dx is going to be negative 2x. And so du over negative 2x equals dx. And so coming back up here, we're going to integrate this. We have an x times 2 to the u, and dx is going to be du over negative 2x. And those x's are going to cancel. And then we're going to move this negative 2 to the outside. And so we have that negative 1/2 integral of 2 to the u du. We do need to reset these endpoints, so let's substitute in. And so that's going to give us negative 3. And if we plug in a 1, we're going to get negative 1. And so now we need to invert those. So we now have a positive 1/2, the integral from negative 3 to negative 1 of 2 to the u du. So evaluating this, we're going to have 1/2 times, and let's see, when we integrate 2 raised to the u power, that's going to be 2 raised to the u over the natural log of 2. And we'll evaluate this from negative 3 to negative 1. And so here again, substituting in, we do need to clear up those negative exponents. So it's going to be 1/2 times 2 to the negative 1. So that's really going to be 1 over 2 times natural log of 2 minus, and 2 to the third, that's going to be 1 over 8 natural log 2. And that's probably about as far as you're going to see that problem. All right, so here, number 18, another classic problem here. We're going to let u equal this exponent, cosine x. And so du dx is going to be negative sine x. And so hopefully we're seeing now the patterns that we need to make sure we do a correct u substitution. And so when we go back, we're going to have the integral of pi raised to the u, and then we have sine x, and then dx is du over negative sine x. Again, we're going to cancel, we're going to move that negative out, so we're going to have the negative integral of pi raised to the u du, and so that's going to be negative, and then we're going to have pi raised to the u over natural log of pi, and then plus c. Right, and again, I would let u here, this one looks so strange, but let's let u be the square root of x, or x to the 1/2. So du dx is going to be 1/2 x to the negative 1/2. And so let's go ahead and do some rewriting with this. So that's du over dx equals 1 over 2x to the 1/2. And so solving for dx, we can just do our cross multiplication here. And so multiply those. We have 2x to the 1/2 du equals dx. And we can come back over here and substitute in. We have, in place of dx, we have 2x to the 1/2 du over the square root of x, which is really just x to the 1/2, and then 2 raised to the u power. And so we can cancel these out, and this 2 I'm going to move outside. And so we have the integral, it's 2 times the integral, and I'm going to flip this over. This is 2 raised to the negative u du. So it's going to be the same formula we've been working with, however it's going to be a negative because of that exponent being negative. So I'm going to go ahead and just jump straight to the answer. That negative because of the exponent, 2, and then it's going to be times 2 to the u, but again, our u value here was the square root of x over the natural log of 2, and then plus c. All right, so for our next problem, number 20, again, as strange as it looks, we're still going to do a u sub here for natural log of x. So du dx is going to be 1 over x. We can do our cross multiplying. And so we've solved for dx. Now back over here, we're going to integrate. That's going to be 4 to the u. And then we're going to have over x, and dx is x times du. So those x's are going to cancel. And so I'm going to integrate 4 to the u du, which again is still just our formula, 4 raised to the u over natural log of 4. And we know that u was the natural log of x, so we're going to have 4 raised to the natural log of x over the natural log of 4. Right, so again, another strange looking problem, but a good place to start a u sub. U equals x squared. So du dx is going to be 2x. And solving for dx, I'm going to have du over 2x equals dx. So back over here we have the integral, we have x, pi raised to the u, and dx is going to be du over 2x. Again, cancel the x's, move out that. So we have 1/2 the integral of pi raised to the u du. So that's going to be 1/2 times pi to the u, and we know u was originally x squared, so pi raised to the x squared over natural log of pi, and then plus c. All right, and it looks like one of the last problems on our packet. Again, I would let u be 2x. So du dx is going to be 2, and so du over 2 equals dx. Back over here we have 3 raised to the u, and dx is going to be du over 2, and we are going to move this 2 out. So I have 1/2 times the integral of 3 to the u du. Let's adjust our endpoints by substituting in here. So I'm going to be integrating from 2 down here to 0. And so let's go ahead and evaluate this. If I integrate, I have 1/2 times, and this is going to be 3 raised to the u power over the natural log of 3. And I am evaluating this from 0 to 2. So we have 1/2 times 3 squared over the natural log of 3 minus 3 to the 0, which is 1 over natural log of 3. So you can see your answer like that. You could also see, since you do have a common denominator, 3 squared is 9, and so 9 minus 1 is 8 over the natural log of 3. Or you could see 8 over 2 natural log 3. Any of that could be the correct answer.